Hello students, so here we have the lecture 1 of aldehyde, ketones and carboxylic acids. Carbonyl compounds. What are carbonyl compounds? The organic compounds that contain carbonyl group, C double bond O group, are called carbonyl compounds. For example, aldehyde, ketones, carboxylic acid, ester, amides, acidic anhydride. Okay, what are aldehydes? Aldehydes are the compounds that hold carbonyl group to which hydrogen is attached on one side and alkyl group or aryl group is attached on the other side. So one atom of hydrogen would be present along with other alkyl or aryl group. For example, CHO group is a formyl group or a aldehyde group. Then ketones. Ketones are those compounds that contain two alkyl groups, two aryl group, one alkyl or one aryl group. Aryl groups can be same, alkyl groups can be same or different. So when these two valencies of the carbonyl group are satisfied by both the alkyl groups or aryl groups or alkyl or aryl groups, then it is called ketonic group. Okay. In aldehyde, what happens? One side you have H and on the other side you have alkyl group or aryl group. But in ketones, you have alkyl groups on both the sides, alkyl or aryl groups on both the sides. You don't have hydrogen here. Okay. So the functional group formula for aldehyde becomes dash CHO and the functional group for ketonic becomes dash dash C double bond O. So C double bond is called a oxo group or a carbon group. Okay. Clear? Okay. Now classification of aldehyde, ketones and carboxylic acids. Classification of aldehydes. The CHO group is attached to sp3 hybridized carbon. Saturated carbon is called aliphatic aldehyde. So when CHO group is attached to the aliphatic carbon, then it is called aliphatic aldehyde. But when it is attached to the aromatic ring, CHO group is attached to the aromatic ring, you call it as aromatic aldehyde. Example of aliphatic aldehyde is formaldehyde, SCHO, acetaldehyde, CH3CHO, propionaldehyde, CH3CH2CHO. Example of aromatic aldehyde is benzaldehyde, salicylaldehyde, nitrobenzaldehyde. Clear? So in nitrobenzaldehyde, what happens? Nitro group is attached to the ring along with the CHO group. Clear? Then ketones are classified into aliphatic ketones and aromatic ketones. Aliphatic ketones means the C double bond O group will be attached to the same or different alkyl groups. Then it is called aliphatic ketones. Now these aliphatic ketones are further divided into simple or mixed ketones. Simple ketones and mixed ketones. Simple ketones are also known as symmetric ketones. That means the C double bond O group is attached to the same alkyl groups on either side. Then it is called simple ketones. Clear? Like dimethyl ketone. CH3 group is attached to CO group. If two C2H5 groups are attached to CO group, then you got a diethyl ketone. Okay. So this is simple ketone. But if two different alkyl groups are attached to the C double bond O, then you call them as mixed ketone or unsymmetrical ketone. So like C2H5CO or CH3, C2H5CO, CH2, CH2, CH3. So it is ethyl methyl ketone or ethyl and propyl ketone, right? Then, so aromatic ketones are the ketones in which the CO group is attached to the two aryl chains or two rings, benzene rings. Then it is called benzophenone. Example is diphenyl ketone. And here you see in acetophenone, one side you have alkyl group and another side of the carbonyl carbon you have benzene ring. So this is also aromatic ketone. So compound in which carbonyl group is attached to either two aryl groups or one aryl or one alkyl group is called an aromatic ketone. So we saw two examples, diphenyl ketone, methyl phenyl ketone. Diphenyl ketone is also known as benzophenone. Methyl phenyl ketone is also known as acetophenone. Okay. Now some of the common flavors are aldehydes. For example, bitter almond flavor is benzaldehyde. Vanilla flavor is vanillin. Cinnamaldehyde flavor is cinnamon. Cinnamaldehyde is a cinnamon flavor and camphor. So these are some of the Commonly available aldehydes and ketones having wide applications. Okay, then classification of carboxylic acid. Aliphatic carboxylic acid are those organic compounds in which COH group is attached to the alkyl group. So for example, CH3COH, here COH group is attached to the methyl group and the name is acetic acid. Then if two carbon alkyl group is attached to COH group, it is propionic acid. So CH3CH2COH, and this is also aliphatic carboxylic acid. Exception here is formic acid, in which the COH group is attached to H, HCOH. So here COH group is not attached to alkyl group, but it is attached to H. Then they are further classified into monocarboxylic acid, dicarboxylic acid, tricarboxylic acid. Example of monocarboxylic acid is propionic acid, in which the COH group is attached to the alkyl group. One COH group is attached to the alkyl group. Then dicarboxylic acid, when two COH groups are attached. An example is oxalic acid. Then when three COH groups are attached, it is citric acid. Example is citric acid. It is called tricarboxylic acid. Clear? Okay. Then aromatic carboxylic acid. Aromatic carboxylic acid is a compound in which one or more carboxylic acid groups are attached to the aromatic ring. They are called aromatic carboxylic acid. For example, benzoic acid, in which one COH group is attached to the benzene ring. Phthalic acid, in which two COH groups are attached to the benzene ring, it is phthalic acid. Then if it is a one COH group and one OCO-CH3 group, it is acetyl salicylic acid, aspirin. So these are the examples of aromatic carboxylic acid. Then you have side chain aromatic acids. The carboxylic group is present in a side chain of the aromatic ring. So here you have the side chain CH2, benzene ring containing CH2, and then to the CH2COH group is attached. So this is phenyl acetic acid. Then they are widely distributed in nature like plants and animals. Lactic acid in curd, citric acid in lemon, acetic acid in vinegar. So these are the widely distributed in nature in plants and animals. Okay. So nomenclature of aldehyde, ketones and carboxylic acid. Nomenclature of aldehydes and carboxylic acid. So first, trivial nomenclature. The trivial name of the aldehyde are derived from trivial name of the carboxylic acid, in which the ending ic acid is replaced by aldehyde. In case of substituted aliphatic aldehyde, acids and aldehydes, the position of substituents is indicated by alpha, beta, gamma and delta. So the carbon atom adjacent to the carbonyl group of carbon is alpha. So carbon atom attached to the carbonyl group indicate alpha carbon. So for example, HCOOH, this is what? Carboxylic acid. The trivial name is formic acid. So the aldehyde of the corresponding carboxylic acid will be SCHO. So the name will be formaldehyde. Ic acid will be replaced by aldehyde. Then CH3COH, acetic acid is a trivial name, and the aldehyde corresponding will be CH3CHO, which is formed acetaldehyde. Okay, ic acid is replaced by aldehyde. Then if you have CH3CH2COH, propionic acid, so the aldehyde will be propionaldehyde, CH3CH2CHO. Okay, then this is CH3CH2CH2COH. N-butyric acid, the 4-carbon acid is called N-butyric acid. The corresponding aldehyde will be CH3CH2CH2CHO, that is the butyraldehyde. Then you have CH3CH2 whole thrice COH. This is 5-carbon and the alkyl group, and the 6-carbon is of the carboxylic group acid. So this is N-valeric acid, and the aldehyde will be valeraldehyde. N-valeraldehyde. Okay, clear? So IUPAC nomenclature of aldehydes and carboxylic acid. So the longest chain of carbon containing CHO and COH group is considered as the parent chain, where CHO and COH groups are given number 1. Then in aldehyde, you have to change the suffix E of alkane by ul, E by ul. So if it is 2 carbon alkane, ethane, so ethane E will be replaced by al, ethanol. In carboxylic acid, E is replaced by oic acid. So if you have CH3COH, 2 carbon chain, so alkane E will be replaced by oic acid. So it will be ethanoic acid. If more than one CHO and COH groups are present, then retain the suffix E and using the di, tri before al or oic acid. Okay, so dioic acid, trioic acid, like that. In alicyclic aldehyde, the CHO group is called carbaldehyde, added after the name of cycloalkane. Okay, cyclopropane carbaldehyde, like that. If alicyclic acid is named as cycloalkane carboxylic acid. Yeah. In substituted aromatic aldehyde of carboxylic acid, 2 or more functional groups attached to the aromatic ring, then a higher priority group is given lower name. If CHO group is a substituent, then use prefix formyl. Okay. So gradually you will understand when you do various examples. So if COH group is prefix, then it's carboxy, and if it is suffix, it is oic acid. Okay. If COR groups is prefix, it is alkoxycarbonyl. If it is suffix, it is OH. If SO3H is prefix, it is sulfo. If it is suffix, it is sulfonic acid. If COX group is a prefix, it is haloformyl. If it is suffix, it is oil halide. If CONH2 group is a prefix, it is carbamoyl. And if it is a suffix, it is amide. When it is a suffix, when it is a higher priority group, and when it is a lower priority group, it is prefix. So CN, cyano, and nitrile is if it is a suffix. NC is isocyano, and if it is a suffix, it is isonitrile. Then ketonic group is keto or oxo if it is a prefix, and if it is a suffix, it is on. OH group, when it is a prefix, it is hydroxy. If it is a suffix, it is all. If it is a NH2 group, it is amino and amine. OR group is alkoxy group anyways. Then if it is a double bond, it is ene, always suffix. And if it is triple bond, it is ine, always suffix. Nitro group is always prefix. X halo group is always a prefix. And R alkyl chain is always a prefix. So if you have this benzene to which CHO group is attached, CH3 is attached, OH is attached. So which group is given preference? CHO group. So main chain is, parent chain is benzaldehyde. Then to benzaldehyde, if you start numbering from here, 1, 2, 3, 4. So on third position it is methyl group, and on fourth position it is hydroxy group. So 4 hydroxy, 3 methyl benzaldehyde. Clear? Then this one, the COH group is attached, OH is attached, and CH3 is attached. So it will be COH group given the parent will be considered with the parent chain, and it is 1, 2, 3. Third position OH group is there, fourth position methyl group is there. So it is 3 hydroxy, 4 methyl benzoic acid. Clear? So let's see the nomenclature of carboxylic acids. Structure, tribal name, IUPAC name. So SCOH, formic acid. So IUPAC name will be what? Methanoic acid, because one carbon acid containing one carbon, methanoic acid. Then CH3COH is acetic acid, ethanoic acid. Then CH3CH2COH is propionic acid, propanoic acid. Then CH3CH2CH2COH N-butyric acid, butanoic acid. Okay. Then CH3 whole twice CHCOH branching on the second carbon, so isobutyric acid, or also called alpha methyl propionic acid. Then let's see the IUPAC name, 2-methyl propanoic acid. Okay. Then CH2 double bond CHCOH acrylic acid, or it is prop 2-enoic acid. Clear? Then 2 COH groups attached, it is oxalic acid, or we can say ethane dioic acid. Benzene with COH group is benzoic acid. IUPAC name also benzoic acid. Then benzene with COH and CH3 is orthotoluic acid, or we can say 2-methyl benzoic acid. Then benzene with COH and OH, salicylic acid, or we can say 2-hydroxybenzoic acid. Benzene with 2 COH groups, phthalic acid, or benzene 1,2-dicarboxylic acid. Okay. Then this one, cyclohexane COH group is attached. Cyclohexyl carboxylic acid or cyclohexane carboxylic acid. Clear? So let's see now the nomenclature of aldehydes. Structure, SCHO, trivial name and IUPAC name. So SCHO is a 1 carbon aldehyde, it is formaldehyde. IUPAC name will be methanol. Then CH3CHO, acetaldehyde, 2 carbon, ethanol, IUPAC name. Then CH3CH2CHO, propione aldehyde, IUPAC name will be propanol. Clear? CH3CH2CH2CHO, butyraldehyde, 4 carbon aldehyde, butanol, butane E replaced by L. Then CH3 whole twice CHCHO. The branching on the second carbon, so isobutyraldehyde, or it will also be called alpha methyl propanaldehyde. And the IUPAC name will be 2-methyl propanol. Then you have CH2 double bond CHCHO. This is acrolein. The IUPAC name will be what? 3 carbon aldehyde. So prop 2 in al. Then CHO. This is glyoxyl, oxaldehyde, and ethane diol. Okay. Benzene with CHO directly attached to the benzene ring. So benzaldehyde. IUPAC name will be also benzaldehyde or also benzene carbaldehyde. Yeah. Then benzene with CHO and CH3. So on ortho position, CH3 is attached to ortho-tolualdehyde and it is 2-methyl benzaldehyde. Okay. Second carbon methyl group is present. Then you have benzene with aldehyde group and OH salicylaldehyde or 2-hydroxybenzaldehyde. Okay. Then you have 2 CHO groups attached to the benzene ring, phthalaldehyde or benzene 1,2-dicarbaldehyde. Okay. Then cyclohexane with CHO group is cyclohexane aldehyde or cyclohexane carbaldehyde. Clear? Okay. So nomenclature of ketones, trivial name. So first write the name of alkyl or aryl group in alphabetical order. Then write the word ketone. In case of substituted aliphatic ketone, the position of substituent indicated by letter alpha, beta, gamma, delta, epsilon. Then the carbon atom attached to the carbonyl group is alpha carbon. Okay. So if you have a 3 carbon ketone, then it will be what? Dimethyl ketone. If you have CH3CO C2H5, then it will be ethyl methyl ketone, alphabetical order. Then IUPAC name will be alkanone. Alkane E replaced by O. So what you have to do there? Longest chain containing carbonyl group considered as a parent chain, and carbonyl group will give the lowest numbering. Now changing the suffix E of parent chain by on. In polyfunctional, highest priority group gives a lower numbering. When ketonic carbonyl group is lowest priority, then it is used as oxo. Oxo prefix will be used. Clear? So if it is a CH3CO CH3, it is 3 carbon ketone, so it will be known as propanone. Propane E will be replaced by O. Okay, clear? Now let's see the nomenclature. Compound, trivial name, IUPAC name. So if you have CH3CO CH3, it is dimethyl ketone, also known as acetone, and the IUPAC name will be propanone. Propane E replaced by O. Then if you have CH3CO CH2 CH3, 4 carbon ketone. So you have ethyl on one side, methyl on another side. We'll be writing it alphabetical order. So ethyl methyl ketone, also called butanone. Okay. Then if you have CH3CO CH2 CH2 CH3. So methyl on one side and propyl on another side. So methyl and propyl ketone. And this is a 5 carbon ketone. So you call it as pentane 2-one. Okay. So pentane 2-one. Then CH3 CH2 CO CH2 CH3. ethyl groups, two ethyl groups on the either side of CO. Then is diethyl ketone, and the IUPAC name will be what? Pentane 3-one. The third carbon CO is there. Then CH3, CHBr, CO, CH2, CH2, CH3. So you have alpha bromoethane derivative. So alpha bromoethyl and propyl ketone. Okay, or we can say 2-bromo hexane 3-one. So hexane 3-one. Okay. Then CH3 whole twice C double bond CH CO CH3. This is methyl oxide, and the IUPAC name will be what? 4-methyl pent 5 carbons, pent 3 in third carbon double bond and 2 on second carbon CO. Then CH3 CO CH2 CO CH2 CH3. That means 2 carbonyl groups are there. So hexane 6 carbon chain, hexane 2,4 dione. Then CH3 CO CH2 CHO. So you have aldehyde group and ketonic group. So then aldehyde becomes a higher priority group, CO becomes a lower priority group. So it is 3-oxobutyral. Okay. Then benzene with CO group. Benzene rings with CO group in diphenyl ketone or benzophenone. Benzophenone is the IUPAC name. Then benzene with COCH3, methyl phenyl ketone or acetophenone. Okay. Then here this is cyclohexane with double bond O and Cl and CH3. So 1, 2, 3, 4. 2-chloro, 4-methyl cyclohexanone. Okay. So let's solve this. 1, 2, 3, 4, 5, 6. 6 carbon. That means hexanal. Then you have 2 methyl groups on the second carbon. So 2,2-dimethyl. And fifth carbon contains 2 bromo groups. So 5,5-dibromo. 5,5-dibromo, 2,2-dimethyl hexanal. Okay. Now this one. 1, 2, 3, 4, 5, 6, 7, 9, 10. So 10 carbon longest chain containing 2 carbonyl groups and 2 methyl groups. So what will be the name? 7-ethyl. Okay. 7th carbon is having ethyl group. 5th carbon is having 2 methyl groups and decane 3,4-dione. Then this one. 1, 2, 3, 4, 5. Pentanal. Huh? Then this one. Benzaldehyde, and you have 1, 2, 3, 4. So 2 methyl groups, 3,4-dimethyl benzaldehyde. Then this one cyclohexanone with methyl groups 2 and 4. 2,4-dimethyl cyclohexanone. Clear? Okay, thank you.